Hi everyone, welcome to GTech Techno Solution Private Limited. Here we are going to see about induction motor and its interview tips. So the first question is, what is the general working principle of induction motor? An electrical motor is such an electromechanical device which tends to convert the electrical energy into the mechanical energy. In case of a three-phase AC operation, most widely used motor is three-phase induction motor. As this type of motor does not require any starting device, or we can simply say that we can use, the reason is that they are self-starting induction motor. So this is all about the general working principle of induction motor. Let's move on to the next question. What is the advantage of skewed stator slots in the rotor of induction motors? The answer is, in terms of the induction motor design, the rotor slots are purposely made with the slight skew arrangement. It will not be parallel to the shaft, and also the skewed stator slots is for the purpose of reducing the magnetic locking, and also we can say that the reducing magnetic attraction between starter and rotor teeth. Let's move on to the next question. What are the various methods of measuring slip? The various methods are as follows. The first one is by actual measurement of rotor speed. The second one is by measurement of rotor frequency, and the third one is stroboscopic method. So these are considered to be the various methods of measuring the slip. Here we have the next question. What are the various methods of speed control in three-phase induction motors? The various methods are control from stator side, and the second one is control from rotor side. In terms of control from stator side methodology, we have the depiction of 3 points. The first one is all about by changing the supply frequency. The second one is by changing the number of stator poles, and the third one is by changing the supply voltage. So if we consider about the control from rotor side, it's all about classified into 3. That is based on by inserting the resistance in rotor circuit. The second one is all about by various ways of cascade connection, and the third one is by injecting the EMF in the rotor circuit. As we know, EMF is nothing but electromagnetic fields. Let's move to the next question. So the question is all about what is meant by crawling in the induction motor. The answer is, induction motors, particularly squirrel cage type induction motors, sometimes it tends to exhibit a tendency to run stably at speeds as low as 1/7 of their synchronous speed. So over here, synchronous speed is represented as ns. S is the base of n. This phenomenon is known as crawling of an induction motor, and the speed is called as crawling speed. You can see over here how the crawling speed of induction motor is depicted. Here we got the next question. What are the advantages and disadvantages of induction motors? The advantages are, it is simple and rugged in construction. It is relatively cheap. If you see about the induction motors requires less maintenance. The induction motor has high efficiency and reasonably good power factor. In terms of the three-phase induction machines, it is said to be the self-starting one. So these are considered to be some of the advantages of induction motors. If you see about the disadvantages, induction motors are essentially a constant speed motor and its speed cannot be changed easily. Its starting torque is inferior to the DC shunt motor. Here we go with the next question. What is the condition for maximum torque in induction motor? The answer is, in terms of the starting torque, it will be the maximum when the rotor resistance per phase is said to be equal to the standstill rotor resistance, that is reactance per phase. Here we go with the next question. What is the condition for maximum torque in induction motor? The answer is, in terms of the starting torque, it will be considered to be the maximum when the rotor resistance per phase is equal to the standstill rotor reactance per phase. So this is all about the conditional specificity in terms of the maximum torque in terms of the induction motor. We got the next question. So we have the slip ring induction motor advantages and the disadvantages that is getting to be compared to the squirrel cage motors. The advantages are high starting torque with low starting current. The next one is smooth acceleration under heavy loads. And the final one is there is no abnormal heating during the starting. So these are considered to be the advantages. If you look at the disadvantages, the first one is the initial and the maintenance cost are greater than those of squirrel cage motors. The speed regulation is poor when run with resistance in the rotor circuit. So this is all about the comparison of advantage and disadvantage over the slip ring induction motor and with the squirrel cage motors. Here we got the next question. What are the methods to control speed of wound rotor motors? The speed of wound rotor motors are changed by changing the slip of the motor. This can be achieved by varying the stator line voltage, by varying the resistance in the rotor circuit, and by inserting and varying a foreign voltage source in the rotor circuit. So these are considered to be the methodologies that is used and deployed in order to control a speed of wound rotor motors. Here we go with the next question. We got to explain how the torque slip characteristics vary when we are trying to add the resistance to the rotor circuit. The answer is the addition of resistance to the rotor circuit tends to be not changing over the value of the maximum torque, but we can say that it only changes the value of the slip at which the maximum torque occurs. You can parallelly find out the torque slip over here, which is depicted. We'll move to the next question. What are the advantages and disadvantages of induction motors? If you see about the advantages, the induction motors are said to be simple and it's rugged in construction, and it is said to be relatively cheap. Other than this, the induction motors require very less maintenance. And also the induction motors have the high efficiency and reasonably the good power factor. So these are considered to be some of the advantages in terms of the induction motors. If we talk about the disadvantages, the induction motors are essentially at a constant speed motor and its speed cannot be changed easily. Its starting torque is inferior to DC shunt motor. So this is the disadvantages in terms of the induction motors. Let's move to the next question. So the next question is, what are the disadvantages of star-delta starting of induction motor? In star-delta starting induction motor, stator is connected in the star connection. For starting after picking up speed, it is getting to be connected to delta connection. When the induction motor is connected in star connection, stator, the phase voltage reduced by 1 divided by 31 divided by 2 times the line voltage. Let's move to the next question. Why is an induction motor sometimes called as rotating transformer? The reason for this was, if we consider about the induction motor sometimes said to be called as the rotating transformer. The reason is that because the stator, that is nothing but the stationary part. So the stator is essentially the primary side of the transformer and the rotor, that is the rotating part, is considered to be the secondary side. So this is the reason why an induction motor is sometimes called as rotating transformer. We'll move to the next question. Why the speed of the physical rotor and the speed of the rotating magnetic field in the stator must be different? The speed of the physical rotor and the speed of the rotating magnetic field in the stator must be different, or else the magnetic field will not be moving relative to the rotor conductors and no currents will be induced. So the next question is, what is the slip? Slip is nothing but serial line internet protocol. If you consider about the serial line internet protocol, the difference between the speed of the rotor and the speed of the rotating magnetic field in the stator is called as slip. It is considered to be the unitless one. And the ratio between the relative speed of the magnetic field as seen by the rotor to the speed of the rotating field will be defined in terms of the serial line internet protocol. That is the concept which lies behind the slip. We got the next question. What is meant by stator? The stationary portion of an electric generator or motor, especially of an induction motor, is called as stator. A row of small stationary aerofoils fixed to the casing of an axial flow turbine positioned between the rotors. The stator consists of wound poles that carry the supply current that induces a magnetic field in the conductor. And the number of poles can vary between motor types, but the poles are always in pairs. So this is all about the stator. How many types of rotor are there? This is the next question. The rotor is a moving component of an electromagnetic system in the electric motor, electric generator, or we can say it in terms of the alternator. Its rotation is due to the interaction between the windings and the magnetic fields, which produces a torque about the rotor axis. There are actually two types of rotors. So the answer are the squirrel cage rotor and the slip ring rotor. We got the next question over here. What is the difference between DC motors and the induction motors? The induction motors has no brushes and is easy to control. Many older DC motors are being replaced with induction motors and accompanying inverters in industrial applications. You can see how come the difference between the direct current motors and the induction motors is mentioned over here indirectly by the combination of the concept which is defined for the brushes and the control. Thank you for watching a GTech video.